Hey. Hey, I'm Matt.
Lindsey.
We're going to teach you about compound inequalities.
Solving and graphing.
It's intense stuff. Let's get to work.
Linear inequalities are inequalities that are linear. Just kidding! Linear inequalities can be written in one of the following forms where a and b are real numbers and a does not equal 0. ax plus b is less than 0. ax plus b is greater than 0. ax plus b is less than or equal to 0. ax plus b is greater than or equal to 0.
Compound inequalities are inequalities that are compound. Psych! So, for compound inequalities, they consist of two simple inequalities joined by and or. In example 1, for and, negative 1 is less than or equal to x, which is less than 2. Here, negative 1 is shaded all the way through for the graph because it is less than x or equal to x. But 2 is open because it is greater than x, just greater than x. For example 2, the or example, x is less than or equal to negative 2, or x is greater than 1. Since x is less than or equal to negative 2, it's shaded all the way through. On the second one, x is greater than 1, so it's just circled. Now this problem is an or problem, so x on this and x on this are not touching. They're pointing the opposite ways. Okay, so now we gotta teach them about compound inequalities and like graphing and solving them.
And an or?
Yeah,
Flip
coin
a
toss?
coin?
Coin toss? Alright.
Yeah.
Heads or tails?
Heads.
Oh, I'm sorry. No, I need that coin. Heads!
It looks like I'm solving compound inequalities for and. So the easy example for this. Negative 5 is less than x plus 1 is less than 4. So first step is to separate them into two separate equations. Negative 5 is less than x plus 1 and x plus 1 is less than 4. Then just solve them as if this were a normal equal sign. So move the 1 over, becomes negative 6 is less than x. For this one, move the 1 over, and this becomes x is less than 3. Then, you plot them on your graph. You plot a negative 6 and a 3. Like this. Then, depending on whether it's equal, less than, greater than, or less than or equal to, or greater than or equal to, you're going to draw a circle, open or closed, in this case open, because it's just less than and greater than. You're going to draw open circles, and since x is greater than 6, it's going this way, and since x is less than 3, it goes this way, and it connects. So all of this is a possibility for x.
What's up with your lines?
They're Mr. Smith lines.
Oh, okay.
Here is an example of a medium and compound inequality. Negative 4 is less than or equal to 2 plus 4x is less than 0. So again, separate them into two problems and just solve. And then do your number line. You're going to place negative 3 halves and negative half on your number line. Going to pretend you're listening to me. Negative 3 halves and negative half. Then since negative 3 halves is less than or equal to x, I'm going to I'm going to fill in that and leave this open since it's just greater than. And then connect them. It's as simple as that. These are all the possibilities of x.
Your line's still kind of funky.
Now for the hard example of our compound inequalities.
It says hard.
Brandon brought that up last class. So our inequality is 0 is less than or equal to 3 halves x plus 3 is less than or equal to 4. So split them into two equations and work them out. Draw your number line. And since both are greater than or less than or equal to, filling them both in and connecting them with your possibilities of x.
Alright, so now we're going to move on to the OR problems. Start with an easy one. X plus 1 is less than negative 3, or x minus 2 is greater than 0. Now, okay, so first thing you do is you separate them into two different problems. After you separate, you're going to go solve it. Markers don't work. Flip the sign, right? Yeah, you flip the sign.
Nope.
Yeah. Nope, no, you don't flip the sign. Oh.
Only on multiplication and division when you carry the negative over, the sign
Don't
is
touch
flipped.
me! Alright, now you're going to go ahead and graph it. So you have this, and you have this, and you're going to put it on one different line. I mean, the same line. Sorry. Getting a little crazy there. Whoop. Boop. 2, negative 4. Then you're going to get here, negative 4. X is less than negative 4. These markers, man. Points outward because it's less than. So anything over here. And this is x is greater than 2. Anything over here. Nothing in the middle. So it shows that anything over here and everything over here works, but nothing in the middle. Next problem is a medium problem. 2 plus 3x is less than negative 13. Or 4 plus 2x is greater than 7. Now to start off this problem, always separate the two problems, then you solve each problem. Graphing. Woo!
Next line.
Thanks. I didn't pull a Mr. Smith. 2. Okay. Now that we have that, we're gonna see that none of them are equal. We don't have to fill it all the way in. We're just gonna circle, circle, circle. Now, again, we point on the outside, signifying that anything here works. And the same thing here, anything on the outside, and nothing in the center. All this one was medium, was just that, this little step here with the extra and the x, just the dividing. Simple stuff though, simple stuff. Moving on to our hard problem. Okay, 0.3x minus 0.5 is less than negative 1.7. Or 0.4x greater than or equal to 2.4. Now again, as usual, make the problem separate and solve them. Okay, now you have your two answers. Now you're going to graph. Oh, crap. Have some change ups. It's -4. Whoop. 6. Whoop. Now, this one is original and simple. Just like that. Because x is less than -4, and you show that this is the one over here, anything. Except this one over here, however, has an equal or greater than. So you're going to have to circle it and shade it in. Then you're going to point it out, notifying that 6 and everything after it can equal x. And again, nothing in the center, as usual. Do you understand this?
Yes.
No questions?
Wait, why?
No, x. Because it's a freaking problem.